It is a pleasure to welcome you to the pitch sharing session of the third edition of the lecture series on advancements in geotechnical engineering, from research to practice. At the pitch sharing session we asked the participants to explain their research with 3 slides and within 5 minutes. They were judged by a 4-member judging panel and the audience members. The pitches that were adjudged as top 3 by the judges and audience members are being shared. The following presentation was from the runner-up of the pitch sharing session adjudged by the judging panel.
Hello everyone, hope you enjoyed the pitching session. I am here to present my pitch on riverbank erosion mitigation via bio-mediated soil improvement. As you have seen that my co-speakers have presented various aspects of biogeotechnics, but the key questions which arises that is it really applicable to the field? See, there are many key challenges which our previous researchers have identified. For example, first of the thing is that how are you going to transport the huge amount of bacteria to site? The second question is that there will be ammonia and non-uniform precipitation. How are you going to encounter that? The third question is the cost is enormously high. So how are you going to counter this? And these kind of questions we hear a lot. Now, considering this, what I have planned in my research that I would try to do some laboratory experiment to facilitate towards the field scale trials from the lab scale study. So what I have done for this, I have adopted, first of all, I have considered 2 hypotheses. First hypothesis is that all the native soils are rich in microbes, and it is a well-proven fact. So if we stimulate the native ureolytic biocementing microbes, we can counter the question of transporting the bacteria and we can reduce the cost. The second hypothesis is that biopolymer is a very good tool for hosting moisture. It is degradable, it is not for a long time, but it can hold moisture content and provide ambient environment for the bacteria for the biocementation. Now, considering this hypothesis, I have adopted 2 strategies for my lab scale studies. The first strategy is that I'm going to use spray technique rather than grouting. Grouting is costly, spray is not. Spraying is convenient for field scale application. Moreover, there are researches which have proven that a thin crust, even a thin crust can resist superficial erosion. Now, considering these facts, I have considered spraying. And the second thing, what I have done is I have used a 12-meter hydraulic channel. And in that, I have tried to simulate a tangential river-like flow. Now, if you can see on the right side, there is figure 1, which shows the results. So the untreated sand, which has been shown with the dotted lines, showed enormous erosion when the velocity is varied from 0 to 0.62 meter per second within a test duration of 45 minutes. On the other hand, the biocement sample, which required 3 cycles of biocementation, have become stable after the critical velocity is reached. And this happened because the erosion occurs at the critical velocity, and the top layer, which is continuously disturbed by spraying, might not be cemented well. If you see, the third sample is the biocement biopolymer composite, and it required only 2 cycles, and it behaved exactly like the biocemented soil with 3 cycles of treatment. So biopolymer reduced the material requirement, which could be beneficial in terms of cost as well as for the environment. Now, considering this fact, the question naturally arises that if you are going to do this, how biopolymer is going to be used. So biopolymer, what we did, we used only a very little quantity of biopolymer, that is 1 gram per liter, and we sprayed it. It was very thin and it was sprayable, but it was in a biofilm phase. So I'm going to show you now a few videos from my experiments, which is only 4 seconds, to show what is exactly happening. See, this is the untreated sand, and this is 1000x video. Within 15 minutes, it got eroded completely. This is the biocemented soil. So you can see that in the sides, it has not been cemented well, and the erosion occurred. If you see, this is the biopolymer layer. Once the erosion occurs, after like critical erosion, it is well cemented all around. and relatively more uniform than the conventionally biocemented soil. So now seeing this, now we are planning to go on a large scale test after this, because we got promising results from our laboratory scale test. Why it is important? See, when where I live, IIT Guwahati, it is adjacent to Brahmaputra River, which is one of the largest river by discharge in the world, and all the rivers across the world have this problem of erosion. I am going to tell you and then show you how severe it is. So I'm going to show you. This is a building which got washed away due to superficial erosion, and in Assam region, the erosion is happening with a rate of 80 square kilometer per year, which is very drastic. Now, how my project is going to change the world? We are providing a technology which could be cost efficient and environmentally friendly. In true terms, lesser ammonia and lesser impact on riparian ecology in terms of external bacteria injection. So with this, I'm going to conclude my presentation. Thank you for your time.